What's going on, y'all? It's Daniel Litwin, the voice of B2B, and welcome to this TMC Thought Leadership discussion. Thanks so much for joining us, and make sure you're heading to our website, Tech MFG, for more content and resources from our entire team as we explore more trends and challenges surrounding vibration control in manufacturing. So let's jump right into it. We have a really timely and unique challenge that semiconductor manufacturers are facing lined up to unpack today to really get the behind the scenes for why this challenge is becoming such a common one in the industry and how to maneuver around it. What am I talking about? Well, we're talking about, due to a mix of trends, things like market-driven shifts, introducing new manufacturing opportunities and growth for semiconductor manufacturers, or specific challenges around upgrading equipment in rather dated facilities. We are increasingly seeing semiconductor manufacturers move their equipment out of the fab and failure analysis lab space, right, into office spaces, or more generally, spaces that weren't built for semiconductor manufacturing. So as we see this trend develop, right, we can quickly start to see that when you're in a manufacturing environment that wasn't designed for precision manufacturing, there's going to be new challenging layers of operations and obviously quality control. So what kind of challenges does manufacturing in a environment that's not specifically tailored for semiconductor manufacturing, how does that impact things like vibration control, right? And how should semiconductor manufacturers maneuver implementing new equipment or rethinking their space to solve for this increasingly common challenge? Well, we're going to break it down here with today's guests. I'm pleased to welcome both of our thought leaders here who are going to break down this trend in the industry. First up, we're joined by Mr. Steve Ryan. He's Divisional Vice President of Business Development at TMC. Steve, welcome to the show. How you doing?
Good, Daniel. How are you?
I'm doing well. Thanks so much for joining us. Real pleasure getting to tap into your insights and thought leadership here today. We're also joined by Mr. Carmen Pistillo. He's founder and president of eQuestis Corp, and he's also TMC's sales rep for the Western region of the U.S. Carmen, welcome to the show. How you doing?
Doing great. Glad to be here and happy to talk about this interesting subject today.
Yeah, thank you again for giving us your perspectives. Just so our audience better understands the lens that both of y'all are coming from as we unpack this trend in semiconductor manufacturing operations, could you give us, both of you, a quick elevator pitch intro here on your background and how that's going to color your perspective and lens here in the discussion today? Steve, we'll start with you.
Well, I've been at TMC for 38 years. My background is an undergraduate degree in physics, and I was in vibration control in nuclear submarines initially, and came here in 1986. And I've kind of grown up with TMC and been really most interested and most focused on the customer application side, the physics of vibration control, what we're able to manufacture to deal with these kind of problems, and what are the technical challenges our customers are having with extraordinarily complex and sensitive equipment. So what we do is we design and manufacture equipment that isolates low frequency, low amplitude building floor vibration from disturbing ultra-sensitive instruments, experiments, and nanotechnology scale manufacturing problems.
And then Carmen, same question your way. Give our audience a little context here on your background and some of the experience you have working with semiconductor manufacturers.
Sure. My background is I'm a graduate from Cleveland State University in chemical engineering. And I cut my teeth in the engineering world, actually working in 3.5 semiconductor research and development, and actually worked in a semiconductor clean room fab as a process engineer, research scientist for about 7 years. And after that tenure, found my way to working with TMC in the world of vibration control because it's so closely tied to the fab environment, and it was a good fit for my past experience. So I've been with TMC for a very long time and have worked in a wide cross section of vibration cancellation, vibration control applications, and have a lot of experience with a wide cross section of customers.
Well, I'm excited to pull from both of y'all's storied careers here in the industry to help us understand this trend, right? So again, we are seeing increasingly more semiconductor manufacturers having to move their manufacturing equipment, which is highly sensitive, which obviously needs to operate in ideal conditions, into non-ideal conditions, right? Spaces that weren't designed for precision manufacturing. Give us a little context around this trend, right? Has this been something the industry has had to deal with in previous chapters, right, of semiconductor manufacturing's maturity? And why are we seeing this pick up now and become a more common challenge?
Yeah, that's a great question, and the question applies to obviously semiconductor fabs as well as other high-tech industries that utilize clean rooms, but certainly the push for trying to adapt to new environments has to do with the short time frame associated with rapid growth that a lot of companies have to deal with, and moving into new locations where they can't really afford the time to build new factories and facilities. So they're kind of forced to look for opportunities with existing structures that are close by that might suit their needs, but might not be optimal for the tools and the environment that they're trying to create for their sensitive, instrumentation.
I completely agree, Carmen. And, what really is driving it is that each semiconductor side, each new generation of computer chips has ever finer scale geometries. And the smaller the geometry of the feature, the smaller the features on the chips, the quieter the floor vibrations need to be to support these advanced manufacturing and inspection and failure analysis tools. And so the fabs are designed to have a certain level of floor vibrations, and having very low floor vibrations is more expensive. So they design parts of the factory to be very, very quiet for the most sensitive tools, and other portions of the factory to be maybe a little less quiet, and other portions of the factory maybe office space or utility areas that aren't very quiet at all. And then as needs change and they have to scramble to accommodate short-term needs, they need to move equipment around, and maybe equipment that was intended to go in the quietest floor space is going then into a less than ideal space or even office space. And that's where these kind of challenges need point of use floor vibration mitigation, right? They're scrambling to try to get back up and running in a less than ideal environment.
And we're going to focus in on the semiconductor manufacturing industry to really hammer home this point. But I do want to make sure that we establish that this isn't just limited to the semiconductor manufacturing industry, and in a lot of ways reflects a common trend where we see industries as, manufacturing expectations change, whether that's equipment, whether that's changes in the market, whether that's new opportunities for company growth. There's always that tug between aligning manufacturing needs with existing facility space. And I'm curious if y'all can give us a little bit of context on which other industries also reflect similar trends, just so we can get a better picture here of this trend, in real time.
That's certainly the case. And as you said, it's not limited to semiconductor fabs. There's a wide range of other technology-based companies, biotechnology, companies that use sensitive metrology tools, nuclear magnetic resonance tools for doing organic chemistry analysis, that have similar vibrational criteria or requirements for the tools that they use for their facilities. So there's a commonality in what's required for enabling those tools from an environmental perspective, whether it's vibration or other environmental concerns that are very similar to the semiconductor industry. So,
one area where we've seen it is an advanced research facility in Manhattan, which was designed to house very vibration sensitive work, was repurposed to support a suite of advanced cryo transmission electron microscopes. And the building floor vibrations were deemed inadequate for that kind of work. And a lot of work had to be done then retroactively to repurpose the building, jackhammer out large concrete sections of floor to repurpose it with point of use vibration cancellation systems to support these electron microscopes.
I've had a similar kind of a scenario where with all of the great planning that they try to put into accommodating the cryo-EM suites to facilitate the environment that they need, ultimately over time it changes and they need to move things or accommodate new tools that are coming in. And I recently had an application where they spent a lot of money on a cryo-EM facility, and 5 years later, 6 years later, a new suite of tools become available, so they have to shuffle things around and accommodate those new tools where they didn't have the forward planning to accommodate all of these. So they do need to move them from time to time into areas that weren't necessarily pre-planned for those tools.
Yeah, and you might think that a lot of time and effort and money goes into planning these facilities. Why can't they plan them so that they're able to accommodate these changing needs over time? And part of the problem is the technology is evolving so quickly that it's difficult to make decisions today based on the type of equipment and its floor vibration specifications and the kind of work you're going to be doing, even just a few years down the road. So we see some customers at things like nanotechnology research facilities that try to delay as long as they possibly can making decisions about floor construction and what they're going to do, because they want to be able to change their mind at the very last minute to take advantage of the latest developments in the technology for the instrument types that they're going to use. Again, advanced cryo-electron microscopes or nuclear magnetic resonance spectrometers for high resolution imaging, things like that.
Yeah, and in addition, their budgets aren't unlimited when they're doing planning, so they have to spend the money in the best way that they can based on the information that they know at that time, and can't double it, what have you, for any future consideration. So they're kind of stuck with what they have, and really that's where TMC comes in to add that value proposition to be able to accommodate that uncertainty in the future that scenario ultimately dictates.
So let's paint the picture a little more tangibly. When we are talking about this trend of moving semiconductor manufacturing equipment out of the perfectly designed manufacturing hub or facility and moving it into semi to not so ideal environments for manufacturing semiconductors, what is really different about that environment, right? Some might say, okay, still got 4 walls and a floor and fluorescent lights above and, an AC. What's the difference? Couldn't we just move the equipment from one room to another, right? What's actually different in a way that impacts the manufacturing process beyond, obviously, some of the quality of life things that come with having a specific manufacturing facility? Break that down. Do a little compare contrast for us.
Yeah, Daniel. So what contributes to how quiet a floor can be is a few things. One is, how quiet is the earth below that building? You can't make a building floor any quieter than the earth beneath it before you started building the buildings. That's number one. Number two is mass and stiffness of the building. So if you want a very quiet site, you're going to certainly start with a quiet greenfield area, but you're also going to have a lot of steel and concrete, much, much thicker concrete pads and steel reinforcement. Another thing is the lowest levels of the building. Ideally, you want to be on the ground floor, slab on grade with a very, very thick slab. Second floor is worse than the first floor. Third floor is worse than the second floor. So you have things like office spaces, which might be on a second or third floor, or some other lighter construction floor, not a heavy pad. where you're starting with worse vibration levels. So if you want to design, quiet level, it means more steel and more concrete, and not so for an office or facilities or other support areas.
Yeah, in addition to that, it's the building geometry as well. Not only the mass of the concrete and so forth, but the vertical height of the building and the different levels that might be in an existing building that's being considered to be occupied. Typically, high or multiple story buildings that are 3, 4, 5 stories or more are going to have much worse horizontal vibration characteristics than buildings that are 1 or 2 stories. And so the higher you go up in a building, typically the worse the vibration conditions are, and all of that needs to be considered when you're considering moving sensitive equipment into those spaces. And as Steve mentioned, there's a standard way to characterize these different buildings, which what's called the VC curves. There's a VC A, B, C, D, and E, which are basically a simplified mathematical formula for characterizing buildings and their vibration levels. And a lot of the equipment manufacturers actually put those specifications in their installation manuals so that the people that are purchasing their sensitive pieces of equipment can take measurements of these buildings and proposed locations and compare it to the requirements of the tool and make a quantitative decision on whether that makes sense or not for them.
Yep. And Carmen, you mentioned, when you start to get to upper level floors, the vibration levels are going to be worse. But once you're off the ground floor, if you're near a structural stanchion, the vibration levels are going to be quieter. If you're near a structural wall, an outer structural wall, a corner wall, the vibration levels are quieter there. So even on a given level floor in a building, the vibration levels are going to vary depending on whether you're in a unsupported section of the floor or an area of the floor that's close to being supported by a stanchion or a structural wall.
And in addition to that, you have things like elevators and so forth that can contribute to vibrations in the low frequency realm. And also, as buildings get more and more populated with other tools, the vibrations tend to increase over time due to the contribution of the noise from those other tools that are placed in the building. So those things need to be taken into consideration. Not only is the building as a static, empty structure, but how is it going to behave as it's populated?
Yep. So external sources of vibration like road traffic, construction, trains, subways, wind on the building, exciting structural resonance, and then internal sources like human footfall, people walking, HVAC equipment, elevators, and as Carmen said, all the machinery that's going to end up going into the building.
Yeah, and Steve, as you mentioned, those different types of vibration sources, their frequencies are different depending on what the source is. And the solution that TMC offers, products they offer, address each of those types of vibrational sources as they change in frequency from low to high. So TMC has a broad spectrum of products that can address each of those and very specifically for the application.
And obviously, when we're talking about vibration control, it's sort of baked in that we're dealing with multiple variables at once. Do you often find that when semiconductor manufacturers are moving their equipment from the ideal facility to the not so ideal office space, that they're introducing layers upon layers of new vibration considerations? Is it usually pretty focused, right? You're solving individual challenges. All right, you've gone up 10 floors and now we just have to deal with height. Or is it usually a pretty complex issue when folks move from one location to another?
Well, I think Carmen touched on it earlier, talking about the VC curves, the generic vibration criteria, right? So there's a vibration specification for the tools based on what the customer wants to get from it in terms of magnification and resolution and so forth. And there's the actual floor vibrations, which we can measure and compare those those two sets of curves, those two curves, the actual floor vibration and the vibration spec of the tool. And from that, you can determine, right, if the floor is exceeding the specifications, how much is it exceeding and over what frequency range. We then look at what we can provide for a transfer function, that is how much we can attenuate over the frequency range, right? In each frequency band, how much can we attenuate that, and we can determine what the solution to get you back within the vibration criteria would look like. So it's very much starting off with the spec. What are the actual floor levels that are being measured, and what's the transfer function that can be applied to get you back into spec?
Yeah, I would agree with you, Steve. It's a very cut and dried application path for customers that we can easily handle and decipher for them. But if you're not in the vibration world, as many of the tool owners are, they don't necessarily know what the basically cut and dried formula is for figuring out what they need to do. So as you said, it basically boils down to those items: is measure quantitatively how the floor is behaving, compare that to the quantitative information and tool spec, and overlay that information to determine how much attenuation is needed from what TMC product to bring the environment into the specification that enables the full capacity of the tool. And that's why customers come to TMC, is we know how to do that. We have that formula, and we can guide them through every step of the way. And TMC is really a full turnkey company for providing all of those services, as Steve mentioned, from measuring the floor and analyzing the data that was measured against the published tool spec, and making a determination of what is the best solution for the customer. So that's all provided by TMC and by the field people that do that.
Agreed, Carmen. I'd agree and say at a high level, that's how the determination is made. But there are some subtle things. For instance, you might determine that, well, we took a vibration measurement on this new site, and it meets the vibration criteria of the tool, but it only meets it by a very small amount. Well, one of the things that's understood in this industry is that in a building, vibration levels rise over time. And there's a rule of thumb that was first put out there by a very prominent vibration consultant called Colin Gordon Associates. And they published a paper that said you should expect vibration levels to rise 17 dB in the first 18 months after the building begins to get populated. You might say, well, why is that? Well, once the building starts getting populated, you have people, you have activity, you have stuff, you have machines, you have lots of things going on. So you should expect vibration levels to rise over time. So yeah, it's comparing the measured core vibration levels to the spec and applying the transfer function, but you need to be conservative and plan for things like vibration levels rising over time, and give yourself a margin of safety.
Yeah, that's a really important point, because if you consider the cost of rigging and bringing in a tool and facilitating a very expensive tool, the cost of doing that, and making a poor decision perhaps on how the tool should be supported and mitigate vibration. Steve's point in that being conservative is a very, very good decision to make in adding more vibration attenuation or cancellation than you need, because if you underestimate what you're needed and you completely facilitate a tool, it's very expensive to try to come back and add things later. So to be conservative and add that extra level of protection is very important and cost effective.
So let's start to get into some of the solutions to this challenge, right? I'm curious, before we get to your sort of summarized go-to bullet points of, you need to adopt this equipment, or you need to try out these strategies as sort of a foundational level for solving this vibration control challenge. What are you seeing from folks in the field today, right? How are semiconductor manufacturing companies attempting to solve this challenge? Where is that working well? Where isn't it working that well? you know, you don't necessarily have to mention specific companies, but if you could give us some specific examples, I think that would help our audience understand this, you know, solution path or journey, right, a little more clearly.
I would say that when the semiconductor manufacturers find that a site is not going to meet the required vibration levels for that instrument, planning ahead for vibration levels to rise over time and so forth, they install what we would call a point of use vibration isolation system. So that would be you know, a platform that goes between the instrument and the floor, or in the case of a raised floor in a clean room, a platform that goes between the instrument and the subfloor, which may be 18-inch, 3 feet, 4 feet down below the raised floor. And the technology in these isolation platforms, I've seen change tremendously in the 38 years that I've been here. You know, back in the 80s, it was air springs, self-leveling air springs. And they worked very well at high frequencies, but not so well at low frequencies. And they were difficult to put under an instrument that was top heavy. And I've seen just remarkable advances in the technology that we can use now to cancel vibrations to a much, much higher degree and over a much, much wider bandwidth than was even close to being possible before. And really what the technology that underlies all that is advances in piezoelectric actuators with high voltage amplifiers, right? So you've got high strobe piezoelectric actuators. A piezoelectric actuator is basically a ceramic, and when you apply a voltage to it, it expands. So if we measure floor vibration in the vertical and horizontal axes, we can take that vibration, we can take that voltage from the vibration sensors, and we can condition the signal and amplify it and run it back to these actuators. So as the floor is moving up and down and side to side, we're measuring that, and we're expanding and contracting piezo stacks to filter that from getting to the payload. Now the piezo stacks are supporting the payload. The floor moves up, the stacks contract, the floor moves down, the stacks expand, and this is happening in X, Y, and Z, pitch, roll, and yaw, all 6 degrees of freedom. And it's a remarkably efficient way to create a very, very quiet pedestal or plinth right underneath the footprint of one of these advanced instruments.
And the beauty of, you know, the products that TMC offers, and Steve used the example of a raised floor, is that basically the floor under the raised floor is called a subfloor. That is usually where you start in measuring vibrations to determine what the tool requires as a baseline. So the rigid floor might be good enough for the tool, but you still need to support it at the raised floor height of, say, 24 or 18 inches. And in some cases, you can actually use a very basic TMC product called a rigid quiet island that basically extends the rigidity of the subfloor up to the raised floor level. But no rigid structure is infinitely stiff, so you have to take that into account when you're building a rigid structure. So in some cases, you can actually use that as a solution. And TMC is an expert at building very rigid structures to support tools where the subfloor is close to what the tool spec is. But in most cases, as Steve mentioned, the subfloor is not at a level that's close to what the tool requires, and you need a more advanced solution. As Steve mentioned, the stasis piezoelectric vibration cancellation system that cancels vibrations in real time and reduces those vibrations. And the beauty of the stasis system is it adapts to the environment as the environment changes, and through the digital controller that controls the piezos, runs it in real time at about 10 kilohertz rate and does the job.
So if you had to summarize then what the best options are for upgrading the destination environment for semiconductor manufacturers, what would those be, right? Because I know some folks may be asking, well, couldn't they just upgrade the whole facility, right? But that obviously comes with a high price tag and a long timeline. And it might still be part of the action plan for the long game, but the short term being multiple years, right, until that new facility is built or that existing facility is upgraded, introduces a period of time where you need some other solutions. So what would those solutions be? Any ideas or tips you would give for upgrading that destination environment?
Yeah, Daniel, I'd say three things. I'd say, first of all, to be conservative, to be planning on vibration levels rising over time, like the 17 dB in 18 months that we talked about. I would say number two is to think in terms of quiet islands, not quiet buildings, right? Because it's very, very expensive to make a building more quiet. It could be, for a typical semiconductor fab, you're talking several 100,000 square feet. It could be on the order of $50 million to make the building quieter by one of the VC levels we discussed, to make it VCD instead of VCD, maybe on that order of magnitude of $50 million. So rather than making the entire building quiet, make the individual points where the most vibration sensitive tools are quiet. Far less expensive and far more efficient, especially if you consider the fact that making the building quieter means just throwing lots and lots more concrete mass at it. And a lot of people are unfamiliar with the fact that concrete contributes on the order of 9% of the world's greenhouse gases. Concrete curing generates a tremendous amount of CO2 and H2O. And so it's a much greener approach to go with these point of view solutions. So rather than trying to make the whole building quiet, it's very inefficient and not very green. Just make it quiet where it needs to be. And I would say the third thing would be to make sure that whatever isolation system you're putting under the tool complements the vibration isolation system that's already built into the tool. So in other words, every one of these instruments that we're talking about that's ultra vibration sensitive already has a vibration isolation system built in, a very good one. And if the floor vibration still doesn't meet the vibration criteria of that tool, it means the vibration isolation system that's built into the tool isn't good enough. It means a second stage of isolation. So if you're putting a second stage of isolation below the tool, going down to the subfloor, that second stage of isolation inherently needs to be compatible with whatever is built into the tool. And that's the beauty of the piezo approach. It was designed specifically to be a second stage of isolation going under a tool that has a low frequency air system built in. And any other approach is basically putting either an active or a passive air system under the air system that's built into the tool. So you're stacking two low frequency springs, and the physics of that starts getting problematic. So those are the three key areas.
Yeah, Steve, old habits are hard to break, especially when new technologies come out that are so much better than the way things had been done in the past. And I know TMC has spent a lot of time with architects and so forth, trying to educate them on what the new technologies that TMC offers can provide for their customers. And, the old-fashioned way of dealing with vibration has been, let's pour concrete and throw mass at the problem. And that was valid before the new technology that TMC offers with the stasis active vibration cancellation systems existed. So, those old habits and ways of thought are hard to break. And I think TMC has been doing a great job with meeting with architects and fab designers to say, hey, you could save a lot of money and use this new technology and save millions of dollars by not throwing so much steel and concrete at the fab and focus on point of view solutions that TMC offers that are mobile. You can move them around as equipment requirements change. You can install these systems and solve a problem as the conditions change, as the tool sets change. Where you can't do that when you're pouring big slabs of concrete across wide areas and spending money that doesn't necessarily need to be spent. So, this new technology, it's an education process, and I know that TMC has spent a lot of time with decision makers in the early stages of fab design and so forth to bring them up to speed that there's a better way to do it.
Yeah, Carmen, you mentioned the architects having a lot of input in these kinds of decisions. And at TMC, as really the thought leaders for this whole world of low frequency, low amplitude building floor control, we've developed a presentation, a talk that's accredited by the American Institute for Architects, the AIA, for ongoing credits for architects. So we do a lunch and learn where we present some of these ideas, what was done historically to solve these kinds of problems, why that's no longer adequate, some of the challenges you run into, what has replaced it and why, and how to avoid running into certain kind of problems. So yeah, we are glad to do that AIA accredited presentation for architects or anybody who's interested in that. Then you can contact us through our website if you're interested.
So just to summarize then, if a semiconductor manufacturer is looking to solve this challenge, right? They have a new manufacturing destination. It's not ideal. It's introducing new vibration challenges. And they consider TMC to be one of the potential solutions partners that will help them resolve these vibration issues. How can they get in touch? Where should we point them? And how can they learn more about some of the specific solutions TMC offers so that they can pick the right solution for their challenge?
Well, TMC has a complete network of global sales contacts all over the world. We've installed our equipment on all 7 continents, including Antarctica. So you can go to our website, and whether it's our local partner in the Western U.S., Carmen, or if it's in Asia, we have local offices and distributors with service teams all over Asia, Europe, just about anywhere in the world where you might expect to see this kind of a semiconductor manufacturing facility. We've got a sales channel that can help you, and the techmfg.com website is the place to start to find the one near you.
And to add on to that, I would say that typically the people that TMC employs in the field to consult with customers have many years of experience solving problems and guiding customers to the best solution. So I think it's unique for TMC specifically is that they have people that have been employed with them for a very, very long time and have a lot of experience. So there's a lot of value added there for the customers to draw on. And as Steve said, connecting with those people, including me, are all there on the TMC website and easy to access and talk to. Just need to pick up the phone.
Yeah, I take pride in the fact that the TMC global sales team is very experienced and very capable and very technical. Typically backgrounds like Carmen's with a degree in engineering or related field. And it's very much like working with a consultant. We're here to help you solve your problem. And if we don't have a product or it doesn't make sense for whatever reason, we're going to do the best we can to help steer you in a direction that makes sense for you. So I would say expect to be treated like you're talking with a consultant that's working with you to help solve your problems and get you where you need to go.
Well, you heard it here first, folks. If this challenge that we just broke down is one that hits home, right? Make sure you're hitting up techmfg.com for more information on how TMC can be a partner in helping you solve your vibration control challenges. So thank you again to the two of you for your analysis today on this increasingly common trend for semiconductor manufacturers and how they can start thinking about the short and long game of solving that challenge. Again, folks, we've been chatting with Steve Ryan, Divisional VP of Business Development for TMC, and Carmen Pistillo, founder and president of eQuestis Corp and TMC sales rep for the Western region of the U.S. Steve and Carmen, great getting to chat with both of you and looking forward to future conversations.
Thank you,
Thanks, Daniel.
Thanks, Carmen.
And thank you, everyone, for tuning in to this TMC Thought Leadership discussion. If you like what you heard and saw here, make sure you're heading to our website, TechMFG, for more content and resources. Till then, I'm Daniel Litwin, the voice of B2B, and we'll catch you on the next video.